Like.
Hello, everyone. Welcome to our January Data Jam stream. My name is Gerarda Nazarko, and I'm a cybersecurity mentor for externship programs here at TripleTen. And tonight I'm very, very excited to be the host of TripleTen's January Code Jam. I'm glad to see all of you that could make it today for the January data stream that we are hosting here at TripleTen. If you are new to this space, let me tell you what a code jam is at TripleTen. It is a friendly competition that occurs for students during their normal coursework. These are super short competitions where a group of our students get together and jam out a bunch of work to meet the prompt. For this event, we'll unite our students from data science and AI ML programs. So we have a collaboration between two programs here at TripleTen. This code jam consists of two parts, working on the project and the presentation. So last week, our participants were divided in teams and challenged to collaboratively explore what truly makes US cities livable beyond simple economic indicators. Using city-level data analysis, visualization, and modeling with real economic data, they had to define livability, compare cities, and surface key drivers and trade-offs shaping quality of life. So it's a pretty interesting project that it is relating to our daily lives. Today, they are going to show us their insights and analysis. Excited to see the results? I am actually. Tonight, we have two teams. They had only 6 days to complete their projects. And today, the teams are going to show off their project. And then the judges will review them next week. So the judges will be evaluating both data, work, and the presentation tonight. We encourage all of you to support our brave participants in the comments. So thank you. Now, it's my honor to present the two teams that we have for tonight. And the first one is team, which has an interesting name, the Urban Legends. And we have Mendel Uzdoba and Kian Maleki, who were the participants. And they have pre-recorded their presentation and we'll play it in a little bit. Once they are done with presentation, we'll ask some questions to our teams about their experience. Showtime. Thank you.
Hey everyone, hope everyone is doing very well. My name is Mendel Uzdoba. I am going to represent the team Urban Legends, which me and Kayan have created together. The idea of this project is to predict which cities are the most livable, and we explore a few different data sets and we decide which data sets have the data to decide which cities are most livable, and we are going to find 3 indicators of what makes a city the most livable. Now, both me and Kayan have contributed to this code. Kayan has been responsible for creating code which cleans the data, and I have refined the code a little bit and used this data to make correlations and decide which features are the most important for making a city livable. And then I made some visualizations and show which cities are the most livable. Like this, everyone can see. Now, unfortunately, Kayan is not able to attend in person because he has something else at this moment. So I am going to represent this team. Now, we have been given a few different data sets which have different features about cities. First, we looked at the demographics data, and the demographics data basically shows that certain cities have more of a certain gender, have more veterans, more immigrants. But after we looked a little bit, we decided that we're not going to use this data set because it's not indicative enough of what makes a city livable. So we started looking into other data sets, and at first I wanted to use the one that had the happiness score. Basically, we saw with correlations that there were certain features which cause a city to have a higher happiness score. And we saw that green space, healthcare, and cost of living all make a city have a higher happiness score. And at first, I really wanted to use this data. I thought it was an excellent indicator. But after I looked at it a little more, I saw that first of all, it doesn't make sense that if you have a higher cost of living, it makes people happier, even though this is the data that showed. It's just that it happens to be that if you have more economic opportunity, then you have a higher happiness score. So I didn't like that piece of data. And also I looked at the green space and the healthcare, and I saw that it actually had a negative relationship with happiness score, which doesn't make any sense. That if you have not a lot of green space or bad healthcare, you're going to be happier. So obviously it had to do with other things, and it just so happened to be that if you live in a city which with better economic opportunity, the likelihood is that you're also not going to have the green space like you would very far out in the country. So we decided we're not going to use that data, and we decided to use a different piece of data as you're going to see. And we decided that there are three very important indicators of a livable city, and those three indicators are education, economy, and air quality, and the matrix of correlation basically shows that these are very strong indicators of livability, and they affect many things about living in a city. So I am just in a moment going to show you guys. I'm going to show you guys the actual code. All right, I have the code pulled up, and I'm going to start going through it. First, obviously, I import all the different libraries that I need, and now we made different functions that we could input the data sets, and this will basically tell us if our data is clean, if there's no duplicates, or if the different features are scaled so they could have equal meaning. They could if some of them are not scaled in the right way, we could make sure they're scaled the right way. So we had to do all that cleaning up, and then we put those data sets into the function. And after that, what we do is we make another function, which is a correlation matrix, which basically sees every single data set and sees the correlationship with the different pieces of data. And as I said in the introduction, at first I wanted to use the happiness score, which showed a very high correlation with cost of living and healthcare and green space. And I wanted to show that if I have green space and healthcare, that's gonna show that we have a high happiness score. But as I explained, it obviously isn't a good enough indicator, because it shows that you have bad healthcare and a lot of green space would basically show that you get a good happiness score, which obviously isn't true. So I had to go through other data, and this is the demographics data, which shows different demographics have to do with other demographics. But again, these are not indicators of what's there's no real good data of what makes a city livable. So I did not take from this data set. And at the end, I ended up using this data set, which if you look carefully at the data set, and this is what I did, we found that the economy, the education, and the environmental quality all are very important in what makes a city a good livable city. So I went with that, and this is what I chose, and I further filtered the data since the project wanted us to find specifically U.S. cities. So I specifically filtered out the data to only show U.S. cities, and when I did, I further first I made a separate column, as you can see here, livability index. So so in this data set, in addition to seeing how high the education is or how high the economy is, I made some sort of column which basically combines these three indicators of livability and made a column which just shows a combination of these three different indicators. And how I combine them, I used something which is called principal component analysis, which I'm not going to go into exactly what that is, but the point is that it makes a one column which shows which cities are more livable and have all these three factors. And then most importantly, I made a heat map with Seaborn, which goes through every single city, and basically the red shows that it has a high score. For example, you see Boston has a high score in education, environmental quality, economy, and every city you could see which ones have a high score in any one of them. And as you go down, it has less and less. The cities down are less livable, they're less popular, and the ones on top are, as you can see, they're really good. Some of them even have a high score in all of them. Some of them have a high score in in economy and education, and some of them just have a high score in 2 out of 3. And as you go down and down, you see that the cities are not as good to live in. I mean, maybe they're good for other things, but in terms of livability, the cities on top score the highest. All right, I hope everyone enjoyed our presentation. I really want to thank again my teammate, Kyan, for helping me and all the hours that he has spent contributing to this project. And I thank you everyone for listening to my presentation.
Thank you. Thank you to the Urban Legend team. We have Mendel today present as a representative from the first team. So I have a few questions for you, Mendel. So how would you describe this experience? It's a collaboration between students from 2 programs, data science and artificial intelligence machine learning program. So can you tell us a little bit more? Which program do you come from and how was the experience? How did you share the responsibilities within this project, which is very relevant to all of us?
Of course. I touched upon it a little bit. I mean, not a lot. I come from data science. I mean, data science. I just finished now sprint 10, and I believe my teammate was doing the other program, the AI program. So the first thing we did was we looked at the data. We're thinking of, right away we thought maybe we're going to use, we're going to do linear regression or something like that, and see what we could predict. But as we're going through the data, we we're trying to see like how we could explain it to just a layperson, like what's a livable city. And first I wanted to use the happiness score, so I found that interesting that yeah, it made sense, there was correlation, but then if I would explain it to someone, it wouldn't make any sense because it doesn't make sense that if there's a negative correlation with green space or negative correlation with healthcare, that you have that's called a livable city because you have bad healthcare. So obviously, like bad healthcare is just an outcome from other things, or bad green space has to do with being in a very economically viable city, but happens to have not good green space. And it's not the green space that makes it livable, what education or things like that that actually makes a livable city. You know, a good economy is what makes. So the experience was for me was like I think it was a very good experience. I got to do something with someone else, which I think was very good. And we had to figure out, you know, together, each do different things. He made a lot of the functions to clean the data, and then I further refined it with some things that I felt that I had to tweak. And I made the visualizations and I made the conclusion. Yeah, I was all in all a good experience.
Yeah. So one question that I have, what are the tools that you guys use to clean the data and then to do the visualization and analysis? Can you explain a little bit more? And
Yeah.
also, were these tools introduced during sprints at at your programs, data science and AI
Y-
ML?
Yeah, so a lot of these tools were like I think they were pandas, basic pandas, and a lot of it most projects in TripleTen, be even like the machine learning. I mean, in the beginning, it's just very basic Python, but we always have to clean the data. And whenever you want to do machine learning on a data set, you have to look at the data set and prepare it, which means you have to make sure there's no duplicates. You have to make sure that they're scaled properly, and that's something which I'm getting more experience as I do more and more projects, and it's coming like more obvious that like the procedure, and I think it will get even more obvious as I go on. That's for the data analysis, and then heat maps was the visualization that I used. I think I used that once or twice, but I was familiar with that. Um, what are the other things? I mean, this project, I didn't use any advanced machine learning. I decided not to use any regression or anything like that. I just didn't think it made sense. But you know, yeah, I thought I used pretty basic tools as more than data analysis. I mean, hopefully in the future I'll get to use more machine learning and stuff like that.
The last question that I have is, how would you rate overall this experience during this code jam? I mean,
Well, I don't
if
know, you know, on what scale I should rate. I mean, it was a good experience, and I think it was more basic. I thought I was expecting a little bit to be a little bit more difficult, which is not necessarily for me. I'm not necessarily disappointed about that, especially as it was the first code jam that I did. So I think it was good that that it was easier, and I got to use GitHub the first time, and it was. But overall, it was a good experience. I think it's good to do things with with another person and see how they think. So I think it was a good experience.
so, also to let you know and everybody else, I mean, there are different tasks each month. So stay tuned if you are interested to participate in these code jams even in the future, because you are up for challenge, and definitely we'll keep that in mind. But
Right.
thank you so much. Thank you so much, team number
Yeah.
one. And now it's time to introduce the second team. As I mentioned, we have only two teams. The second one is Common Data. We have India Bas and Kamil Dobilov as team members in this collaboration. And India is present today, and I think she's the one presenting for the entire team. Fortunately, the Kamil couldn't be here tonight. So, India, we are ready for you. Thank you.
Alright.
Can you share the screen, please?
Yeah. Okay, here we are. Let me scroll up here. Okay, so yeah, so we're team com and data. So com for Camille and for India data. So for our project, we use basically urban analytics, livability scores, and the US census demographics to build a city level data set across multiple dimensions like housing, safety, education, environment, and also opportunity. So in our project, you will realize that early analysis showed that the economy score barely varied across cities. So it wasn't useful. What was useful were the trade-offs though. Especially between safety and housing affordability, which showed a strong negative relationship. Um, let's see here. So like instead of forcing a single livability score, we use clustering to let the data define city types. The results showed two clear profiles. The first group consists of more affordable cities with strong housing scores, but weaker opportunity metrics. And the cities are accessible, but may offer fewer innovation-driven advantages. So here you'll see the imports and the libraries loaded. That's that. Um, so here basically a few cities right here like New York, Los Angeles, and Chicago. And this is like traffic, green space, air quality, happiness score, cost of living, healthcare index. And this is also well this is we have Glen Burling. Okay, so this is the US cities. So I see that we have here other countries as well. Let's go down further here. So cities in this profile concentrate opportunity related advantages but face clear housing costs. Um, pressures. And this is the trade-off economy versus cost of living in the US cities. So we have a few cities, Texas or states, Texas, Idaho, Tennessee, Oklahoma, Kentucky, Iowa, Arizona, and Wisconsin. And it shows basically almost every point sits at the same economy score of 6.52, forming a near vertical line. Cost of living varies, but economy barely changes. This matters because it suggests that the economy is effectively constant in the US subset. We can't use economy as a driver of livability in this data set as is because it contains almost no information No meaningful variation. Any economy versus cost trade-off can't be measured here. It's a data set limitation, not a real world chain. The red flag here is that there's also an extreme outlier with cost of living, which equals 0, which is suspicious for a city score and may distort models. And then our second visualization, safety isn't free. Trade-offs were hunting safer cities may have tougher housing scores, often affordability or availability. So this is our plot right here, trade-off safety versus housing. These are US cities as well. So what this graph shows is that a negative relationship internegative relationship between, safety versus housing. And this is a text with livability trade-off involving one dimension often comes with pain elsewhere, which is housing. Um, the best cities aren't the ones that maximize everything. They're the ones that chose a trade-off that sets you up nicely for livability profiles later. And then we have another visualization, which is environment versus hustle. And this also includes the cities that are shown here, cities in the states. So what this graph shows is that a mild negative trend, which is higher startup intensity, often corresponds to slightly lower environmental quality, but with lots of scatter. Why this matters, this suggests that the trade-off is not absolute. Some cities manage strong startup ecosystems without destroying environmental scores. The insights on this is that the scatter implies multiple models of success. So there's high startups and mild, low environment, quality first cities, lower startups, high environment. Then next we have our matrix right here, which shows housing, cost of living, safety, healthcare, education, and all that is listed here. So this, the economy row column is blank, confirming it's not usable. So the housing cost of living strongly positive, which is 0.77. Education, venture capital strongly positive as well. In this plot, the startups, venture capital also looks strong. And these correlations hint at bundles of city traits, which is exactly what you need to define a livability definition. So that's that. These are just more data that we imported. So as we scroll down here, so as we come down here, these are the cities and states that We came up with scores for the housing, cost of living, safety, healthcare, education, environmental quality, commute, startups, and venture capital. And these are the differences within the results that we were able to come up with. Um, Here's another livability profile cluster. And so basically, the interpretation of the first cluster plot is the city score better on housing and cost of living dimensions, but tend to have weaker startups, ecosystems, and lower education safety scores in the data set. The next plot, innovation and opportunity. So basically, those cities concentrate opportunity related factors and tend to have better safety commute scores, but pay for it with weaker housing and cost of living scores. So, and the livability beyond cost alone, the comparison shows that the higher cost of living does not consistently correspond to higher happiness or better environmental conditions. Several cities achieve moderate to high happiness scores despite lower costs, indicating that livability is shaped by multiple non-economic factors. Um, and for opportunity and affordability trade-off across the city types, using the clustering results from the urban area score data sets, cities are grouped based on opportunity-related variables, such as startups, venture capital, and education, and affordability-related variables, housing and cost of living. Cluster level averages reveal a clear trade-off. Cities with strong innovation and education systems tend to have worse housing affordability and higher living costs, while more affordable cities exhibit weaker opportunity signals. For demographic context for livability outcomes, using the U.S. cities demographics data sets, population level measures are aggregated at the city level across race categories. These demographic characteristics include total population, median age, household size, and foreign-born population, which are compared to livability related outcomes such as happiness score and the healthcare index. And also the cities that defy opportunity affordability trade-off. Within each cluster, cities are compared to the cluster average livability score. Cities that score higher than their cluster average despite similar opportunities and affordability profiles are identified as outperformers, while those scoring below underperform. These cases highlight the livability outcomes that are not mechanically determined by economic structure alone, suggesting that local conditions and policy choices influence quality of life. And that's all of our presentation for tonight.
You're all you on mute.
Sorry, our host has some problems. Just 1 second.
Connected. Can you hear me?
Yes, now it's good.
Yeah.
Okay. So, overall, based on your analysis, what are the cities that are best to live based on the elements that you selected that are more important when we evaluate the quality
So the
of a
cities that
city?
are best to live, I actually have that note to be here. One moment.
Because as I saw in your analysis, you consider also globally, you consider also cities outside US, but also you had some analysis based only on US cities.
Mm-hmm.
Based on
So,
that analysis, what was your conclusion as a team
our
or
conclusion as a
recommendation?
team, um, trying to find the plot here, but our conclusion as a team, I know that we came up with Cincinnati, Ohio for the US cities for affordability and housing. They had stronger affordability and housing. And for innovation and opportunity, we came up with Seattle, Washington.
Okay, okay. So how would you rate overall this experience working with another student from a different program than yours? How was this
The
experience?
experience, it was pretty good. I'm in the data science program. And working with Camille, it was pretty nice. We were able to, you know, bring our thoughts and our, learning styles together to work together as a team. He was pretty busy on his end. That's why he couldn't make it tonight. And also, I was pretty busy as well, but we were still able to communicate and, talk things out and keep in communication to bring together a project. So.
Thank you, India, and thank you, team number 2, Common Data. Thank you, both teams, the Urban Legends and Common Data, for your hard work, for your participation, and for your presentation. And also thank you for your recommendation based on your analysis. What are the best livable cities that you did for the last 6 days? That's all from us here at TripleTen, the January Data Jam presentation. Thank you so much for watching us. If you are a TripleTen student and you are interested in participation, check out your career channels in the hub, where you can find more information about the upcoming events. I would like also to send a special thank you to the organizers of this event. Thank you for organizing this Code Jam. Marcela, Danielle, Liana, Natasha, Olivia, Dennis, Anastasia. Thank you so much. Thank you again to all the participants for presenting your work today. We are continually impressed by what you built, and events like this wouldn't be possible without such enthusiastic and brave students. One more time, my name is Erarda Nazarko, and thank you all for watching us tonight, and see you on the next event. Thank you for watching and have a great evening.
Have a good night.
Thank you.